Assalamu alaikum dear student. Welcome to the course of Electric Machine 2, lecture number 18. Today we are going to study the starting methods of a three-phase induction motor in induction motor rating. So why we need a starting method for a three-phase induction motor is you people know that at the time of starting the rotor is at stationary and the back EMF due to the rotation is not developed yet, hence the motor draw a high starting current. Starter is used in order to limit the high starting current. We use different starter for both the types of three-phase induction motor. So initially when we need to limit the high starting current, we use a starter, and a stationary rotor don't have EMF, so that's why it required some sort of resistance or any other method to limit the starting current. First of all, starting of squirrel cage motors of an induction motor, the method is using primary resistors. In this matter, external resistance are connected in series with each phase of the stator winding during starting. This causes voltage drop across the resistance, so that the voltage available across the motor terminal is reduced and hence the starting current. The starting resistance are gradually cut out in steps, 2 or more steps from the stator circuit as the motor picks up speed. When the motor attains a rated speed, the resistance are completely cut out and full line voltage is applied to the rotor. We know that the torque equation of a three-phase induction motor, the starting torque is approximately proportional to the square of the applied voltage. So when we reduce the applied voltage, definitely the current as well as the starting torque will be reduced. So this method is generally used for smooth starting of a small induction motor, and we not use it where we required a high starting torque. The second of the method for the starting of a squirrel cage motor is auto transformer. Auto transformer are also known as auto starter. They can be used for both star and delta connected squirrel cage motor. It is basically a three-phase step-down transformer with different tapes provided that permits the user to start the motor at say 50, 60%, 80% of the line voltage with the help of these tapes. At the instant of starting, the changeover switch is thrown to start position. This puts the auto transformer in the circuit and thus reduced voltage is applied to the circuit. Consequently, starting current is limited to safe value when the motor attain about 80% of the normal speed. The changeover switch is thrown to run position. This take out of the auto transformer from the circuit and puts the motor to full line voltage. Auto transformer starting has several advantages, that is low power loss, low starting current and less radiated heat. For large machine over 25 horsepower, this method of starting is often used. This method can be used for both star and delta connection motors. The starting of a squirrel cage motor, another method, that is star delta starters. This method is used in motor which are designed to run on delta connected starter. A two-way switch is used to connect the stator winding in star while starting and in delta while running at normal speed. When the stator winding is star connected initially, voltage over each phase in motor will be reduced by the factor 1 by square root under root 3 of that would be for delta connected winding. The starting torque will be 1 by 3 times that it will be for delta connected winding. Hence, a star delta starter is equivalent to an auto transformer of the ratio 1 divided by square root 3 or 58% reduced voltage. So in all these three methods, we reduce the input voltage to the stator. So we also called these three methods the reduced applied or supply voltage method. So these are for the starting of a squirrel cage motors. Now starting of a slip ring motors. That are the two basic type of rotor we have. So slip ring motor are started by rotor resistance starting. In this matter, a variable star connected rheostat is connected in rotor circuit through slip rings and full voltage is applied to the stator winding. At starting, the handle of rheostat is set in the off position so that the maximum resistance is placed in each phase of the rotor circuit. This reduces the starting current. At the same time, starting torque is increased. As the motor picks up speed, the handle of rheostat is gradually moved in clockwise direction and cut out the external resistance in each phase of the rotor circuit. When the motor attains its normal speed, the changeover switch is on position and the whole external resistance is cut out from the rotor circuit. So we add the resistance initially, and when the motor attains its speed, we remove it. Now induction motor rating. When you see in induction motor, there is a nameplate on a three-phase induction motor. Some information regarding the rating is provided on it. So these are the horsepower, the speed, the line current, line voltage, temperature rise and frequency are mentioned on these nameplate of a three-phase induction motor. The horsepower rating is the mechanical output of the motor when it is operated at rated line voltage, rated frequency and rated speed. Under these conditions, the line current is that specified on nameplate and the temperature rise does not exceed that specified. The speed given on nameplate is the actual speed of the motor at rated full load. It is not the synchronous speed. So keep it in mind that the speed provided on nameplate is the actual speed of the motor at full load and it is not the synchronous speed. Thank you.